Hi guys, welcome back to Pirates of Maths. This is my second video for circle theory. If you not watch my first video for circle theory, that's a better idea. You just go and watch them first and then you can come to this video after that, because today we're going to do more exam question and sample questions. So watch them first and then you can come here.
Now we can go straight to the question number 1. A, B, C and D are points on the circumference of a circle. Center O. AC is the diameter of the circle. AC and BD intersect at E. Angle CAB is equal to 25 degrees. Angle DEC is equal to 100 degrees. Work out the size of angle DAC. You must show all your working. If you like, you can pause the video and give it a try.
Okay, now we can solve this question together. This is the circle and center is O, and we need to find the angle DAC. Angle DEC, this angle is 100, so we know this angle is going to be 100 as well, because AC and BD, line AC and line BD cross each other on point E, and these two angles are vertically opposite angles, so they are equal. So we can write down that DEC, angle DEC is equal to angle AEB. So now we found this angle is 100. So if you mention about this AEB triangle, we know this angle is 25 and this is 100. So we can find this angle, because angles in a triangle add to 180. So we can write down that angle ABE plus angle BAE plus angle AEB is 180, because we can write down the reason. Angles in a triangle add to 180. So we can write down this ABE, angle ABE plus BAC is 25 plus AEB is 100 is equal to 180. So angle ABE is equal to 180 minus 125. It gives 55 degrees. So if we found this angle is 55. And you know this AC is a diameter. Therefore, this angle is right angle, 90 degrees, because as per the circle theorem, a semicircle, angles in a semicircle is 90 degrees. Therefore, we can write down angle ABC is equal 90, because we can write down angle in a semicircle is 90 degrees. So we know this is 90. Therefore, this angle is going to be 90 minus 55. So that is going to be 35. So we can write down that angle ABD, this angle, plus angle DBC is equal 90. these two angles. So angle ABD is a 55 plus angle DBC is 90. Therefore, angle DBC is equal 90 minus 55 and it's give 35 degrees. So we found this is 35, and angle DBC, this angle, and then angle DAC, this angle, they both are in the same segment, so they are equal. So if you watch this, CD is a chord, they are making two angles in a circumference. This angle and this angle, they are equal because same segment. We can write down that angle DAC is equal to angle DBC, because angles in a same segment are equal. So therefore, DAC is equal to DBC, and we found the DBC is 35, so angle DAC is 35. The answer.
B, C and D are points on the circumference of a circle, center O. ABE, ADF are tangents to the circle. Angle DAB is equal to 40 degrees and angle CBE is equal to 75 degrees. Work out the size of angle ODC. You can pause the video and give it a try to find the angle ODC.
Now we can do the second question, and here angle DAB is 40 degrees and angle CBE is 75, and we need to find angle ODC, this angle. Okay, so this is a tangent and this is a tangent. So we know this angle, put in a red color, this angle is right angle, 90 degrees, because the radius and the tangent meets at 90. And this is 90 as well, because the radius and the tangent meet at 90.
So when we mentioned that ABOD quadrilateral,
we know this angle is 90, this angle is 90, and this angle is 40. And we can find this angle.
because in a quadrilateral, some of the angles are at 360.
So we can tell here, we need to write down everything. So angle ODA is 90 degrees, and angle OBA also 90 degrees, because radius meet tangent at 90. Right. And we can write down angle DAB plus angle ABO or OBA plus angle ODA plus angle DOB or BOD. Angle BOD is 360 degrees. So we can put the amount. DAB is 40 and OBA is 90 degrees. ODA is 90 as well. and BOD, we don't know that, is 360. 220 plus BOD is 360 degrees. So BOD, angle BOD is 360 minus 220 degrees. It's going to be 140 degrees. So we found this angle is 140. Therefore, angle BCD is 70 because angle at center is double of angle at circumference. So we can write it down there. Angle BCD is half of angle BOD because angle at center double the angle at circumference. So BCD is, angle BCD is half amount of BOD is 140. So it's going to be 70 degrees. So this is 70 degrees. So I can delete this page. So we found this BCD is 70, and now this angle is going to be 15 degrees because this is the right angle as well. So it's going to be 15 degrees. So we can write it down there. Angle OBC plus angle CBE, angle CBE is 90 degrees because you can write down angle OBE is 90 degrees. Radius and tangent meet at 90. So angle OBC plus angle CBE is a 75, we know that, equal 90. So angle OBC is 90 minus 75, so it's going to be 15 degrees. So this is 15 degrees. Okay, now we found this angle is 15 and this is 70, and we can find this angle because an angle around the point is 360. This is 140, so this is going to be 220. So we can write down a reflex angle BOD is 360 minus 140 and it's 220. So this is 220, this is 15, this is 70. OBCD is a quadrilateral. It's a funny shape, but it's still quadrilateral. So the angle at to 360. So we can write down angle ODC. So I just write down here angle ODC, I put here, plus angle OBC plus angle BCD plus angle reflex angle BOD. Is at to 360 degrees. You can write down OBCD is a quadrilateral. So we can put the amounts. So ODC we need to find. So I put ODC plus OBC is 15 degrees plus BCD is 70 degrees and reflex angle BOD is 220 at to 360. So ODC is, we can add together, it's going to be 305. So ODC is 360 minus 305, that's going to be 55 degrees. So this is 55 degrees. That's the answer.
M, N and S are points on a circle C1. RST is a tangent to C1. Circle C2 passes through the center O, S and M of circle C1. Prove that SM is not a diameter of the circle C2. Give the reasons for your answer. You may pause the video and give it a try.
So now we can solve this last question together. And there's two circles C1 and C2. Angle MST is 48 degrees. And now we need to show that line SM is not a diameter of circle C2. So whenever we mention about the diameter, there's a suitable law in a circle theorem that angle in the semicircle is 90 degrees. So what we do, we need to make an angle whatever the chord is making. So what I'll do, I'm just connecting this O and M and connecting the point O and S. So we know that angle OST is 90 degrees because this is center, so this is the radius and tangent meet at 90. So this is 90 degrees. But this is 48. So we know angle OSM is equal angle OST minus angle MST. Because this angle is equal to take away this 48 from the right angle. So OST is 90 and MST is 48. So angle OSM is going to be 42. So this angle is 42. And you know, this is the OS is a radius and OM also a radius. So this angle is going to be 42 as well. So we can tell OS equal OM because they are radius of circle C1. Therefore, so hence OMS, angle OMS is equal to OSM. So angle OMS and angle OSM, angle OMS and angle OSM equal 42 degrees. So whenever we mention about this triangle OMS, we know this angle is 42 and this angle is 42. So we can find angle SOM. So angle SOM plus angle OMS plus angle OSM add to 180 degrees, because angles in a triangle add to 180 degrees. So it gives SOM is equal 180 minus 84. So that is 96 degrees. And we can tell angle SOM is not 90 degrees. So SM is not a diameter. And you can tell the reason that angle in a semicircle is 90 degrees. So this is the proof. So this is the end of this video, and I cover the part 1 and part 2 for the circle theorem. And if you have more questions, you can ask me and I can do another video for you. And next video we're gonna see another exciting chapter. Thank you.